Hi, everyone. Thank you for joining us today. My name is Richard. It's nice to meet you all. We wanted to bring together this event before the school year starts because I think many of us, including myself, are starting to plan for the next school year, thinking about how to spend our time. We think now is a good time for us to get a better understanding of the career landscape for machine learning and some career advice on how to prepare and succeed. We also wanted to show that there's a community of like-minded machine learning students around called the UTMIST. And you can subscribe to us, join our initiatives, and join our team to be able to gain more exposure and experience in machine learning. So the title of this event is also our event breakdown, which is very convenient. So first, let's get to the info session. We are the University of Toronto Machine Intelligence Student Team, or UTMIST for short. We provide an inclusive environment for those interested in machine learning. So you can come together and learn together through courses, through paper reading sessions, through projects, through listening and building connections in our events, and to ultimately clear the mist around machine intelligence. I would like to introduce you to the organizing team for UTMIST this year. They will be the ones ensuring that everyone involved in our projects and events can get good experiences. So what are some of the initiatives that we work on? A big part of UTMIST is facilitated machine learning projects. Every year, we take on a few interesting ideas, either applying machine learning to solve complicated real-world problems or chasing cutting-edge research in machine learning. Our developers build websites that can predict home prices based on images. Research groups affiliated with UTMIST have published their own academic papers while in their undergrad years. We organize events and talks frequently, where we invite distinguished researchers and industry experts to share the latest breakthroughs and applications related to machine intelligence. Many of them are also sharing opportunities for you to join their team as an intern. Now, if you're new to machine learning, we have free courses that are designed by students for students called the MIST 101 and MIST 102, and they're available on our YouTube channel. We also have our own newsletters covering the latest conference papers, and industry news to thousands of readers. Last year, through the pandemic, we focused on building a Discord community online where we can share machine learning resources and help one another. New for this year, we're also building a mentorship program targeted for different levels of learners. There are also many exciting initiatives that we are planning out. And this ties to a question that I want to ask you guys. So we would like to take a 1 minute time to do a quick survey to understand more about your needs. Which of the initiatives that we mentioned do we find more interesting and that you can benefit most? And an optional question, we would love to hear about your suggestions of some possible initiatives that you hope UTMIST can deliver. So it will help us a lot if you can go on menti.com, enter the 8-digit codes 56394282, and write down 3 initiatives that you like or hope that UTMIST can do. So please do that now, and we will wait for a minute. And in the meantime, I would like to ask Charlie, who is monitoring the Mentimeter, to share with us some results. Charlie, any interesting results?
Yeah, I see most people are very interested in the machine learning projects. and our talks and workshops events. Yeah, I see more answers coming. Yeah, thank you guys for the interest. We'll keep all these in our mind in the future. And I
Right.
also see some suggestions. Yeah, they're pretty good ideas. Thanks.
Okay, great. We're going to move on now. Thank you so much for your help. And now let's cover the structure of the organizing team at UTMIST. So working at UTMIST is about gaining meaningful skills and connections. There are essentially three components: projects, events, and content. The first few departments on the right are focusing on projects. Infrastructure develops new features to our website and finds ways to improve our compute. Academics and research, as well as engineering, works on implementing machine learning projects. They, as well as the industry relations team, will also work on developing different events that cater towards developers, student researchers, beginners, and more. And then there's the content. Marketing focuses on finding ways to grow our organization. Technical writers focus on discovering, understanding, and informing others about exciting things in machine learning. So a common question that we always receive is, what is the difference between academic projects and engineering projects, and what do these teams do? So academic works on understanding and contributing to the forefront of machine learning. They strive to be student researchers. They organize academic events to learn more about recent research work. Engineering projects focus on building and deploying machine learning models for a specific application and use case. They also organize events such as project showcase at the end of the school year and other workshops focusing on skills development. So we have a few current openings right now. Most of these positions will finish recruitment before the school year starts. Now, you might have read about it on our website. If not, you can read more about them after the event. So now we want to do something fun here. On top of your head, or based on the title of the positions, I would like to ask you all, which positions would you be more interested or curious about? So we have prepared some interesting facts and stories about the positions, and you can help us decide which positions to cover during this info session. Please go to menti.com and use the same code that we provided earlier. So just to let you guys see, these are the available positions, and we're going to cover some of the most interesting ones or most popular ones. So maybe let's give a minute. Okay, so I would like to ask Charlie again to share maybe the top 3 most popular positions. Charlie?
So the current top 3 are project developer, project director, and technical writer.
Okay, awesome. So now I would like to ask my colleagues Vicky, Charlie, and Hetav to briefly talk about these positions with me. So first we have project developer. Oh.
So if you're a project developer, you will be able to work with a group of intelligent students. Being a project developer means sometimes you will get coder's block. Sometimes a code that was returning an error all of a sudden starts functioning as desired, but you have no recollections of what you did to actually fix the problem. But at the end, you will gain valuable experiences and so many skills.
Great, I think that's relevant to a lot of us here. Next, we have project director.
So if you're the project director, you will be leading a project team and work with other students. Being a project director means sometimes you'll find that things will not go as planned, but you will learn how to be flexible and make updates accordingly.
Awesome. Next, I think I prepared for this one is technical writers. So right now, I'm currently also working as a machine learning research intern. And I find that a lot of the interns' work includes reading, understanding, and presenting academic papers to a group of colleagues. So that's essentially what technical writers will do, right? So I guess technical writers really helps you to prepare for this machine learning researcher role. So I guess since we have some time left, we're going to cover the remaining positions as well. So I'm going to start from the top and we'll work our way around to the bottom. So we have research director and developer.
Right. So research directors and developers deal with some of the latest advances in technology. It surely has its own bag full of perks, but there's one major challenge. You go to your old friend Google to get some conceptual help, and surprise, the mighty Google is also clueless on some of the latest technologies, and so you'll have to find your own way around by reading more research papers.
Great. Yeah, next we have graphic designer.
Graphic designing is an iterative process. You might present 2 designs, and you might also be asked to produce a 3rd one. And after some discussion and deliberation, they may go forward with the first one. But let me tell you, there's nothing more rewarding than your designs being used to represent the club and its initiatives.
For sure, and you're helping us to grow UTMIST even further. And next we have language specialist Chinese. Okay, so this is an interesting one. So our club was actually founded in 2017. One of the co-founders is here with us today as a panelist. And our club was founded primarily by Chinese engineering science students. And we therefore have a WeChat official account similar to a Facebook page. And we will continue with this tradition. And I hope our founding members are not disappointed with us. In us. Okay, next we have mentor.
So mentors are like your friends. They're going to help you when you are stuck with different challenges, and they're your go-to person in case of technical or conceptual difficulties. But at the same time, mentors are not expected to be walking Wikipedias. It's normal for them to not know the answer right away. They're like TAs who will help you and guide you in the process of making your own project.
Mm-hmm. I think mentor is a good role because it's very hard for us as machine learning students to learn about different fields of machine learning at the same time, but being a mentor allows you to do so. So mentoring others is also helping you to learn. Next, we have photographer and videographer. So I prepared for this one. So last year, we actually did recruit a few photographers, videographers. However, because of the pandemic, they didn't actually get a chance to pick up cameras at all last year. But we did have fun. They did have fun screen recording, editing videos, and building our YouTube website channel, which is new for last year. In the end, we uploaded 35 videos for that year, and we reached 123 subscribers last time I checked. So then now we have industry event directors.
As an event director in the industry department, your routine will be emailing or talking to the industry partners in person. So a lot of times you need to know their interests as best as you can, even before you're reaching out to them to make a successful negotiation. So sometimes you will be like emailing the startup CEO saying, would you be interested in speaking at our event? Our students are brilliant. And they will be like, great, would you be interested in promoting our solutions? Our product is brilliant. So if this negotiation happens in person, it might be even more intense. And if they are quite skillful and powerful at speech, you may even forget your initial desired outcome before coming to this meeting and just agree with whatever they say. So just remember to keep fighting for the club.
Great. I'm sure Charlie has a lot of experiences in this. She was a president at UTMIST a few years ago. So next we have academic event director, and I prepared for this slide, right? So for me, when I was helping to organize the academic events, I learned that if you do your research, learn more about the speakers, be a good host, and ask good questions at the end of the event, good things will happen. The speakers will remember you. They will even reach out to you after the event, and you will get a lot of opportunities this way. So next up, I think that covers all the positions, right? So we're gonna have a summary slide for the info session. I hope you find our info session informative. Just to summarize, UTMIST hosts a whole suite of initiatives throughout the year. For those looking for more project experiences, we will be building our project team soon. We also host talks, workshops, and events on a regular basis for a diverse range of machine learning students. We have a machine learning crash course for those new to machine learning called UTMIST 101 and UTMIST 102. We have our all machine learning newsletter with over 1,000 subscribers. For more details, you can visit our website and join our Discord server. And we will also be sharing more relevant links after the career panel. And by the way, if you have any question related to our club, feel free to enter our Discord server and ask these questions in the general channel. So Charlie will be monitoring those questions and will be answering those questions throughout the event after. And after the career panel, a few of us will also stick around to answer any questions related to the club. So now it's time for the second half of the event, career panel. I would like to hand it over to Vicky, the moderator for the event.
All right. So good morning, everybody. Welcome to the UTMIST panel. We have a tremendous panel. I appreciate all of you for being here. My name is Vicky Chen, and I will be moderating this discussion. And today with me are our guests, Siyan, Yuchen, Jing, Colin, and Julie. Let me do a brief introduction of each panelist first. I will start with Siyan. Siyan is an incoming fourth-year engineering science student majoring in machine intelligence. Previously, she interned at NVIDIA, where she worked on self-driving planning. She's now working on self-driving perceptions at Huawei's NOAA Arc Lab for her PY internship. Our next panelist is Yuchen. Yuchen recently finished her undergrad in computer science and statistics. Her study focuses on machine learning, including multiple ML research experience. She's going to Stanford this fall to pursue an MSCS degree. Next, we have Jing. Jing is a recent graduate in engineering science, majoring in machine intelligence. He previously interned at Layer 6 AI, where he conducted research on a recommendation system. He will be attending Cornell University this fall to pursue a PhD degree in computer science. His interests include mathematical reasoning with machine learning and machine learning security. The next panelist is Colin. Colin was one of our co-founders and second president at UTMIST. He's a PhD student at University of California, Berkeley, where his research focuses on reinforcement learning. And last but not least, we have Julie. Julie is a recent graduate from UofT, specializing in computer science with a focus in artificial intelligence. Previously, she was a data engineer and software engineer intern in several financial technology companies in Toronto. She's now working as a machine learning engineer at Cash App. That's our panelists for today, so without further ado, let's get right into it. The goal of the next hour is to examine career in artificial intelligence. So here is how the next hour will work. We will do a few rounds of questions to get to know more about our panelists, their experiences, and some of the useful resources. We will have 10 minutes at the end for Q&A. If you have questions you want to ask the panelists, you can post it on Mentimeter. The link is in the chat. Now let's get started. I will start the discussion with the more high-level questions. So I will start with Siyan. So Siyan, why did you pick machine learning? How did you get into and eventually choose machine learning as your current career path?
Yeah. Thanks, Vicky. I think for this question, I would answer that I think I am mainly influenced by my first machine learning research experience in my second year. And at that time, I was working under a postdoc in the lab and started learning the basics in deep learning and later on read through papers in the research topic we're working on. And I think that's when I got inspired and became interested in the challenges in AI and decided to dive deeper into the field. Yeah.
Thank you for sharing. And I will also ask Yuchen here about the same questions. We know you're going to Stanford this September, so why grad school? How did you get into and eventually choose machine learning as your current path?
I chose machine learning as my career path because in second year, I watched a presentation about Google Duplex. This is an AI assistant product that uses very natural human voice to conduct conversations over phones. I was super impressed at that time that AI ML could do such advanced tasks. So I started my journey in this area. So I chose courses all about machine learning in my third year, and I was lucky enough to be involved in multiple ML research experience. I chose grad school because I realized that machine learning has become a predominant area in computer science. ML gathers all the smartest people around the world. So maybe I should open my eyes and see other options in computer science. While I still have passion for machine learning, it is always good to prepare yourself for more useful skills other than machine learning. So I decided to go to grad school and explore more other possibilities.
That's great. Thank you, Yuchen. And to continue on this topic, Julie, could you share a little bit about how you pick machine learning as your current career path?
Yeah, so it was actually after my first internship. The internship was supposed to be kind of like the data engineering role, but halfway through it, there was an opportunity to kind of work on some of the machine learning things that they were doing, like the pipeline work. So I got really interested in that. So that when I went back in my third year at UofT, I started taking the ML courses and stuff. So I was able to prepare for an actual machine learning internship, which I had last fall. And then from there, I went back to UofT, finished the undergrad, did another machine learning course, and then decided to work full time in what they call the like half software engineering, half machine learning kind of hybrid role.
Thank you for sharing. And now we're going to change it up a little bit for Colin and Jean. We'll start with Colin. How did you get interested in machine learning at the beginning? And what did you do to stick to that interest? What makes you go beyond the general interest?
Yeah, thanks. So I guess for me, I first got interested in machine learning when I was actually doing research related to robotics. I had the fortune of working with Professor Angela Scholik, working on robotics applications. And then the professor actually got super interested in machine learning. And she asked us to look into this direction and basically figure out if we can do anything with robots. And then I suddenly know this is like a really big field and there are a lot of excitement in it. And that's how I kind of know about machine learning that can already do powerful things. And that's how I really started to get interested in machine learning. And what I do to stick with the interest, this is not really I need to put extra effort to stick to the interest, because it just kind of grow and grow as there are more and more impressive results coming out. and all the research community, they have really impressive like image generation results and all the like deepfake and everything, and like the deep learning beat the benchmark of like image classification, and that was like really what's making me my interest like grow, kind of fuel my interest along the way. And I think for me to go beyond the general interest, I guess this is more more because of I did some research with it, and I get to learn sort of the details and kind of mechanism behind how to make it actually work. And that kind of makes me want to figure out exactly what goes like what can make it better, what can we do to make it better. And I think that actually helped me to like get more and more interested in the area, because like that you can maybe do something better and kind of push the field a little bit further if you can try hard enough. I guess not like other field, there are a lot of like fundamental work that you need to learn through. There's some low hanging fruit when like 2 or 3 years ago when I was starting out, that I feel like, oh, if I did something and then I can already make an impact in the community, and that kind of like, it's a really great feeling. I feel like that kind of also helped me getting more interest in terms of like doing like eventually doing research in the field. Yeah, so that's kind of like the story, how I got interested and how I was like going kind of beyond just being interesting in it and getting actually some research.
That's great. We'll ask more about your research in the later questions. How about you, Jin? What's your process like? How did you get interested in machine learning?
Yeah, for sure. So, in my second year, I think I wasn't really sure which option I should pursue in my third year for engineering science. And one day, after thermodynamics course, I think there was some event happening, and then I just walk into that event. It was actually the annual general meeting, the AGM of UTMIST in their first year. And then it was quite interesting. They basically invited Michael Gurdjieff, a professor that taught us, programming courses, talk about machine learning. And it was quite interesting to get to know machine learning, because prior to that, I basically have no idea what machine learning does, except this word I heard a lot of times from other people. And then I think that's how I get interested in machine learning at the very beginning. Later on, I think in my second year summer, I did some research on recommender system with Professor Scott Senner. And then I see that machine learning can actually do the sort of recommendation, help you discover items that you've never thought about or purchase by doing something called collaborative filtering. And then I think this is a really powerful thing. And then later on also continue this path in my internship. That's how I kind of started machine learning, maybe just by sheer chance, but later on I found out it's actually a really powerful thing that I can also benefit a lot of people in application domain.
That's great. Thank you, Jin. And I think this is a good segue to our next topic, and we'll start with Colin this time. What's your typical day like as a PhD student and researcher at UC Berkeley? What aspects of the jobs are most appealing or least appealing?
Right. I guess a typical day is a hard question to answer, because I guess as a kind of research student, you sometimes get like unexpected things out of the topic that you work on. So there's not like a typical, nothing really typical, but basically one change, I will talk about the change shift from undergrad. So one thing that I noticed is that as a PhD student, you do get a lot more meetings than as an undergrad student, and that could feel pretty like exciting and kind of like exhausted sometimes when you have like too many meetings. I don't know if it's just like Zoom fatigue or anything, but you do feel like you're kind of diving into this pool of a lot of excitement around just all the ideas that you're talking to different peoples in your peers and to your advisors, and kind of like the day in the life is more like you do like research, kind of feel like throwing ideas around, and a lot of time is more like on yourself though, compared to undergrad. You're kind of like working on your own, figuring out like maybe like writing out the code for your project. That's like also another aspect of the day in life. And I guess another transition like shift from undergrad I experienced was that I sort of feel kind of the objective, or like in back in undergrad I had like a clear objective, which was like getting good grades and getting like good curriculum activity like experience, and also kind of like getting good research opportunities, and that's like kind of like a clear objective. But once you get into a PhD, it's sort of like you have to kind of define your own objective. You have to like kind of define what kind of research you're really interested in doing, and ultimately you'll be the expert as a PhD student in the field that you actually work on, and that's something that you really believe in, where other people might not be, even if even your advisor. So that's like something really different that I feel as a PhD student. And I guess like for sometimes in the day, like as a typical day, I just like kind of pondering a lot about like what I really want to work on, and kind of like wandering around about different projects. That's kind of like, I would say it's more like fluid compared to undergrad. It's kind of like fixed schedule. You go to core classes and you kind of work on with homework and everything. So that's like a big transition. I feel that's pretty interesting. So I guess this is a nice aspect of the job. Like you get to, I guess speaking of job, it's more like kind of like a training. I would say it's a job, but it's also like kind of training yourself to know what you really want to, like how to do research and what you really want to work on. So this is a nice aspect of the research, is because like you kind of are kind of like actively asking yourself what you're most interested in, and you're actually trying to do something with it, and it just makes this experience more exciting. I guess the least appealing part is also kind of also along the same line, where you really don't know what you really want. And in the research, for example, I was like pretty excited about a lot of like vision stuff at the beginning of my first year, related to reinforcement learning. But then I later found out that maybe I was like not that excited, but like you spend a lot of time into it already. So that's like kind of like you're feeling like maybe you're not being productive. So that might be like the least appealing part of a PhD student. And also, I guess like the sense of really clear objective sometimes is unclear compared to like an undergrad experience. But I would say that's kind of like kind of a double sword, because that's like the appealing part. Well, it could be very like not appealing at times. Yeah, I guess that's kind of like what I feel. I could add more, I guess, later.
That's great. One follow-up question with that. What are you working on right now? And could you share a little bit about that?
Yeah, so one of my recent project is using kind of like language model in in reinforcement learning. So that's kind of trying to see if we can bring the benefit of kind of large language model, such as like transformers. I'm not sure like many of you guys have heard of it. It's like a really big language model that can basically exile a lot of like language modeling tasks. And we see the connection that like reinforcement learning is kind of like a sequence modeling problem similar to language. And we kind of want to bring this transformer architecture into RL, reinforcement learning, and see how well that works. And so that's one of the reasons that I got interested in, because I saw that there's like a kind of opportunity to really push the boundary of like how good we can make RL perform. And another thing that I kind of get interested in is sort of how do we incorporate human in the loop more efficiently, and that's kind of ties into a lot of like practical problems of robotics, where you see there are a lot of like robots that need a lot of training data to be collected in a real world. But sometimes it's dangerous to do that because you don't know like what kind of behavior, like there are a lot of like unexpected things happening in real world. So there needs to be human to correct them, like their behavior. And like the problem there is that sometimes just using human demonstration, for example, using human to drive the robot, can be very ineffective, although it can give like a really great training data. So like the question is that can we use another way or a better form of feedback to really make the whole feedback loop or training robot in the real world more efficient. So that's like one thing that I got recently excited as well. And I guess I'm still kind of exploring different topics. So I also get excited about like a bunch of other stuff related to kind of how to compute derivatives fast in the neural net. But yeah, they're kind of like just some topics that I got like interested in. Like once you get into PhD, you will just find that there are just so many good ideas around it, and you always get so excited about them. But yeah,
That's
that's
great.
like the current two that I focus on the most.
Yeah, that's great. Thank you, Colin. What about you, Slian? What's your day like doing internship at Huawei and NVIDIA?
Yeah. I think in the two working experience that I had, there's a part that is the same in both the companies, and I think it's in most research jobs. That is when I would be given a research problem, and I would be tackling this problem mostly independently on my own. And as for daily routine, I think it is largely depend on the current research progress. Sometimes I would be figuring out the cause of a PyTorch bug, or sometimes I would be browsing papers to find a way around a model deficiency and how to improve it. I think it's overall like an iteration of finding problems, solving problems, and meeting new problems, and then solving that problems. Yeah, I think that's my daily routine.
That's great. So is there a lot of paper reading involved?
Yeah, definitely. Especially in the early stage of research, there's a large amount of time spent on the literature review in that field.
Interesting. And what would you say is the difference between school and PY internship?
I would say in school, I think when we're taking courses, there's a clear path, there's a clear milestone we can make. But as in PY, when doing research, I think it is less guaranteed to make progress and get immediate feedback on the research project we're working on.
That's interesting. And do you like school more or PY, the internship? Do you prefer internship?
Yeah, personally, I prefer internship. I think it is more freedom. Yeah.
Yeah. Yeah, I have the same feelings. but school is fun too.
Yeah.
Thank you, Thian. I'll also ask Julie about this question. What's your typical day like as machine learning engineer, and what do you like about your job?
So yeah, typical day looks a lot at like, I do a lot of work on deploying models and like making them scalable. So it has a lot to do with like things like your aux scores and stuff aren't as important anymore. What's important is like latency and optimizing those kind of metrics. So it gets really interesting because you see it in a very different way than academia does with machine learning, where a lot of the times, you know, certain metrics have to be met. You know, you're trying to make a model that has really high predictions, but now you're thinking about things like, okay, how do I make it so that things are fast, because there's going to be millions of people who are going to hit this model. So your questions and everything you do just becomes a little bit more different when you're a machine learning engineer. And then in addition to that, I would say that like what's really nice about like, I guess my role specifically is that I do still have opportunities to do research. So on Fridays, I have what they call my banana day, my research day, where I can dive into more specific things, whatever topic I want, and kind of bring forward that. And it doesn't have to do anything with like the actual finance company. So Fridays are like that. I'm working on like a real-time verification, like video thing for Cash App that I wanted to work on. So that's what I'm doing on Friday, which is like completely different than my actual job, Monday to Thursdays. So I really enjoy that part. But really, it's just like you are the connection between production and like the machine learning modelers. So the modelers at like my company are the ones that just spend their whole day modeling and like coming up with new things to like incorporate into the systems, and then we take over, create the pipelines. And still you have to have a very strong understanding of like how modeling and how machine learning works, or else you're not going to be able to actually automate that. So yeah, I guess that would be kind of like my typical day. What I like about it is that I'm not completely like tied down to one particular aspect. Like I don't only do modeling, I don't only do like software engineering work. It's kind of a nice mix of both, and there's a nice balance. I get to pick between how much I want to invest in each one. What I don't like about it is because it's kind of like a new thing. There's no real clarity as to like what the next steps in your career ladder are. Yeah, I think that's the part that maybe is a little not the nicest. Yeah.
Yeah, thank you for sharing. I know that in school, when we get a project, there's a clear things written down what you need to do. So in industry, how do you approach a problem? Is there like a clear step-by-step process?
Sometimes there isn't. I mean, I would say most of the time it isn't. I mean, when I get projects, for example, they have what they call OKRs, which is just like, you have the quarter and we want to be able to do this. And then you have to kind of just plan out how are you going to get there, right? And you have to get to those like targets. But like how you choose to do that, and how you, like, no one's going to tell you, hey, you have until like this Friday, you're going to submit this part, and the next Friday, you're going to submit the next part. It's very self-sustained. You have to be able to be good with your time management and stuff. It's not like school where there's like, I guess, you know, there's always those like, if you have homework, you know, you'll be caught up on like the stuff, whatever you're learning. Whereas with industry, it's very much, it's a lot of independent work. There's a lot of pairing that goes on, which is nice. But yeah, it's very much figure it out yourself. A lot of Googling, I would say, happens.
Yep. Yeah, Google is our friend. Thank you, Julie. Now that we know a little bit more about what it is like working in machine learning, let's ask Jin about some useful resources. Jin, could you share the process of getting started on learning machine learning and some of the resources that are helpful?
Yeah, so I think generally speaking, UofT courses, machine learning courses are great. For engineering science, machine intelligence option, we have these mandatory machine learning courses. I think computer science department also have those equivalent ones that you get really familiar and then have a good understanding of machine learning. I think one particular one is the CSC 413. I think it's about deep learning, and then it's taught by very knowledgeable professors that are doing great research. Say if you are maybe first year or second year, and then you want to get a head start on machine learning, but you are blocked by this prerequisite of these machine learning courses, then you can look around maybe I think YouTube back then when I kind of started. And then now I think people also talk about kind of Coursera. They have a lot of different machine learning courses. Some are quite short. They are really focused on one or two specific kind of techniques, but there are also some they are quite comprehensive. So I think those are some good resources. And I think they will have some lectures, assignments, or something like that, so that you can also check your understanding by actually coding things up. So it's really just similar to a course that you do on your own. I also heard there are also some books or lecture notes that people post online that might get you started as well. Personally, I didn't kind of start in that way. I started by watching those lectures. But those are the ways that I can think of getting started.
Yeah, thank you, Jin. There are definitely a lot of useful courses at UofT. And you also mentioned YouTube channel, Coursera. Are there any YouTube channel that you follow personally that you like to look at?
Yeah, I think when I started, there was this, I think Stanford, it has this course called CS231 or something like that. That talks about kind of image recognition, things like that. And then I think that course particularly talks about kind of those CNN's image understanding. Unlike kind of maybe CSC 413, it talks about more. But I would generally say, just look at kind of their views, and then also things like that. Like the ones that are most popular are either they are kind of general enough to a lot of audience that are useful to get started, or they are really good ones that people just watch and rewatch over and over again. So probably those are the criteria that I follow. See which channels or videos that you want to watch. At the beginning.
Definitely. Many good university, I think MIT, Stanford, they have like open lectures and they post it on YouTube. I heard you also mentioned books and lecture notes in AI. Do you read books related to AI during your free times?
Well, I think for books, because once they are written, they are kind of hard to update sometimes. So that I mean, this in my opinion, I think it's good to kind of learn the basics from the books, and then whenever you are dealing with kind of a specific research problem, then maybe you want to kind of read those specific papers. They are current, and then also those conference papers, things like that. So I think those books are really good at talking about those sort of basic understandings, right? How you can, also those linear algebra things that are quite important as well.
Thank you, Jin. And to continue on this train of thought, Yuchen, which courses in your UofT undergrad years were your favorite and found most helpful? And what education preparations you feel would be the best?
Yes, so my favorite course is actually Math 137. There's a sentence that I like very much, saying math is the foundation of statistics, and statistics is the foundation of everything. And 137 turns out to be the foundation in mathematics. The 137 materials helped me the most throughout my undergraduate studies. So I needed to review the videos that Professor Alfonso made for us from time to time. It's very helpful, even when you're studying upper year statistics and mathematics, even computer science courses. Education preparation really depends on the career path that you would like to choose. If you would like to do research in machine learning, you'll need to take many math and stats courses. For example, APM 462 convex optimization and STA 347 probability and STA 447 stochastic processes, etc., etc. I actually typed online notes for these courses, and I am sharing them to the chat right now.
Yeah, thank you.
Yeah, and on the other hand, if you like to go to industry for a machine learning job, you should probably take more programming language courses. For example, computer networks systems or programming on the web. Those would prepare you the best for programming. So you would have more advantages in an industry job. That's the best suggestions I could give.
Yeah, definitely. If you want to do research in machine learning, you'll need a strong math background, math, linear algebra, and I think previously June mentioned there are some courses like CSC 413. Did you take those?
Yes, CSC 412, 413, and 311. I think those are introduction to machine learning. And if you are really interested in machine learning, you should definitely consider them first. Yeah.
Yeah, and there's another one, APS 360. I think that's also an introduction to machine learning. I think that.
Yeah, that's under the engineering department, I believe.
Oh, I see. And what is the first course that you took that's related to machine learning and programming?
The first course I took about machine learning is 311, CSC 311.
I see. Yeah, thank you for sharing. Those are a lot of like useful resources, and I know a lot of people are interested in getting internship either for a summer or PY. So Cian, what's your process of getting different internship, and what are some resources you find helpful?
Yeah, sure. During my job hunting period after third year, sorry, the resources that I find useful is firstly, of course, the PY portal in the engineering department and the CS department too. I think at that time I saw there are a bunch of machine learning related jobs posted in that portal. And also the career fairs held by many different clubs at that time is also very helpful. I think when you attend a career fair, you can directly interact with the HR or the interviewers, and you can hand in your resume to them. I think that's a good opportunity. And as for the interview preparation, I would say for a research positions, apart from the GPA and coding skills, it would be good for you to demonstrate your passion for the research area that you applied for. And I think the interviewers will expect you to tell them about the details of your past research experience if you have any. And I would say that one recommendation is if you read the papers in the field and thinking about how it can be improved before the interview, that would be a great for the interview. Yeah.
Yeah, so research positions are important and PY portals are helpful. Career fair are also very helpful for getting internships. That's great. Thank you, Cian. What about you, Julie? What's your process on securing jobs, and what are some resources you found helpful?
Yeah, so I actually didn't end up doing PY. because I wanted to graduate faster. So I went through the whole, like I made myself a co-op thing. So every summer I would just do the internships. And the way I got those internships was through networking events. So the CS department does have, a lot of the times they'll have like companies come in and sometimes they'll just do like a resume review and like you just have to like, or recruiters will come in, or maybe some like software eng people will come in just to like do a chat or something. And so I would go to those events and I would talk to those people. I would connect with people on LinkedIn and like just message them and just have like a coffee chat, not even necessarily asking for a job, but just, figuring out like, what is it that I even want to do in the summers? Because I wanted to explore different career paths. And then they would kind of guide me to be like, oh, if you're interested in this, you should talk to this person in this company. It's like one of my friends. And then they would refer me. And then that's how I actually got all my internships. I never really did the whole application stuff. I got it through networking and talking to people. I find that to be really, really useful. And in terms of like even preparing and like what skills were super useful, I would say that for a lot of, if you're going to go into like any engineering, like software engineering, machine learning engineering kind of role, you do have to have like a strong programming understanding. So like, I would say you would need at least like up until like the end of second year worth of like the computer science courses. I'm not sure how it works with engineering science or the kind of programs you guys learn, but like having a strong basis of like your algorithms and design principles, like knowing about dynamic programming, all these other things is like super helpful for securing the internship. I would say that some companies look at GPA, but I've never had a company really ask me for my GPA. It's more about like the skills you have, soft and technical, and having like a personal project or something that like showcases like almost like your portfolio, like what you can do. Technical interviews are usually like there's like 3 or 4 with the company, and they'll like make you do stuff so that that's sufficient enough for them to know like how strong you are technically. So I would say if you're like prepared to do all that stuff with like what's it called, leak code or something, that's like super useful. I would say that's how you would get ready for an internship and even a full-time career at the end.
Yeah, that's great. So there's leak code for preparing for the technical part of the interview. And for networking, you can go to LinkedIn to connect with different people. And you also mentioned your networking event at UofT or coffee chat.
Yeah. If you go to like, I think the CS, like you just go to the websites, like the UofT websites, they usually have like a bunch of networking things that are going on. And like even finding there's like a mentorship program, I think after 3rd year that you can like apply for, where they like connect you to someone in industry. And I would say that everyone should have a mentor in undergrad that can really help you. Someone who you kind of see yourself being in the next 3 years. Once you establish that person, I feel like whether you go into research or post-grad or even just going into a career, that person is going to be a very useful tool, very useful resource.
Yeah, definitely. Thank you for sharing. And for the people that are thinking about grad school, Yuchen, what's your process of applying and choosing grad school? What are some resources you found helpful?
So most graduate school programs open their application system in the fall season, but I would recommend not to submit your application until a few days before their deadlines. Each school will have a different deadline. So by submitting late, your profile packages will be the most up to date, and the reviewing committee actually starts reviewing all people's application after the deadline. So that's a small tip. And the most helpful resource is actually the people around you at UofT. Go have a coffee chat with your professors. That's the most useful resource. They may write you a recommendation letter, or they may provide life-changing advices. Also, when I was writing up my statement of purpose, I turned to UofT Writing Center. because they have seen so many likewise essays. So they provide you proofreading service and they provide you suggestions about the structure of your essay. I found that helpful.
Yeah, that's great. Thank you. UofT Writing Center is definitely a great place to go. And you mentioned coffee chat with professor. Do you usually email the professor or approach them after class?
Before COVID, I often approach them after class, or even when I don't have their classes, I would go up the Bayhan Center and actually just run into a professor and talk to them. In this way, I had a lot of conversations with different professors, and I remember in the undergrad computer science office, they also provide appointments for academic advising. That's also a very useful resource, and that's a way you can talk to a teaching stream professor in computer science department.
Thank you. And to follow up with that question, did you take GRE? Is GPA and publication important for grad applications?
Yes, in my case, I applied to master's programs only, and I would say GRE and GPA are so important in my application. But I didn't have any publications, so I think undergraduate students don't need to worry about publications unless you're applying to top PhD programs.
Thank you. And the next question is for Colin and Jean. What skills and experiences do you feel are the most important to prepare you for this career, or path that you can't necessarily learn from school?
I can start first. So one thing that I would say is one thing that I guess like maybe not necessarily can learn from school is to pick up things really quickly. So this is like kind of in the sense that you are kind of like getting into a literature review, and then you found out that there are kind of like a new domain or new set of method that you completely didn't wasn't familiar with before. And what typically was really helpful during research is to actually read them and figure out roughly what they are talking about really quickly, and they can speed up the research process, and actually it help. I found it to be really helpful for me to actually give up early, which is another like really valuable skill. I feel like I'm still like not really good at. Like know when to give up. It's like another kind of like good skill to have. It's like sometimes you put into some time and effort into it, and then you feel like this is like it's like hard to give up, and you run into the sunk cost fallacy. And I feel that a lot, because sometimes a project is just like definitely going to kind of like fail at the end, but I guess the amount of work you already put into it makes you don't want to give up that early, and you still feel like there's something that you could do. But again, there's some trade-off between like high risk project and like the project that's likely to success but have less impact. So yeah, I guess like it's like hard to balance out. And I found out that having a really good balance of like knowing when to give up and when to like invest your time quickly, like learn stuff is very important. As my experience.
Yeah, absolutely. I heard that you mentioned sunk cost fallacy, and just curious, Julie, does it happen in industry that you guys find this project is just may not work, and you decided to
all the time?
All the time.
All the time. I literally on Friday, we were like something I was working on for the last month. We were like, never mind, let's do it another way. 1 month worth of work just out the door, in literally a meeting. It happens all the time. Yeah, don't get tied down to your project. They could disappear the next day.
Yeah. So continue on the skills and experiences. What about you, Jin? Do you have any? What do you think are the most important skills and experience?
Yeah, I think Sian mentioned something about when you are doing research on like doing a course or some sort of capstone project, you don't have very clear milestones, or you don't have an immediate the sort of feedback coming up. So it's really important to kind of manage or understand your project well, right? And then with some unobserved or unpredictable information, because specifically you need to be in charge of your project. Then you need to know which stage you are at, and then yeah, I think this is sometimes really hard because you might encounter some problems later on, or you might have currently a few problems that you need to address before making this entire either pipeline or project working. So I think these are some things that we didn't learn back in the courses because they were structured in a way such that you only have one path, and then you just go from here to there, and then you have a clear signal whether your test cases pass or things like that. But here in research, I guess you really need to design your own this kind of timeline or things like that. I guess another thing that's also related to kind of what Colin mentioned is, maybe you really need to be good at analyzing negative results, because you will get a lot of them, and then you need to know kind of what might be the problems for it, and then how you can solve that in some ways, and then because sometimes it could be a simple bug that's easy to fix. Sometimes it could be actually some kind of deeper research question that's by itself can be as challenging as your current project. Then you need to kind of at least kind of figure out what the problem is, and then you need to maybe demonstrate this by having some simple cases that it should work, or if they're not worked, exactly what the problem is. And I think this is something that's quite important, that if at the end still it is a much deeper problem, then you might need to switch gears and then maybe address that problem first, or switch to another project. So I think these are quite important skills that it's hard to learn from courses.
Yeah, thanks for pointing it out. I'm glad that we touched on the soft skill aspect. Now let's move on to the last topic of today. And after this, we will open it up to the audience for a Q&A. So looking toward the future, what are some applications that your current or future area of research could apply to that you're most excited about? And let's start with Colin.
Thanks. I think so. Currently, I'm working in RL and more sort of like focusing on how to make like more efficient RL algorithms that could potentially be applied to like real world applications such as the human in the loop. Like how do we get more efficient human feedback? So I guess the natural applications of that will be eventually we might be able to get robots, like more and more robotics, or like assistant in home health whole setting, where a human can interact with them more like comfortably and smoothly. So that would be kind of like one of the application I could think of, and I guess another one that could be to building like more efficient system, such that we can actually deploying like maybe like AI system into a self-driving scenario, but that would be kind of long term because like safety is like a big concern, and I feel like a lot of time the work I'm doing, we haven't really considered a lot of our safety. We're more like on the side of pushing the benchmark, making everything as efficient as possible. But on the safety side, I feel like we haven't paid much attention yet. But that's definitely something that I think will be very excited in the future once we have figured out how to make them efficiently, and we could start to think about how to make them really, really safe. That's kind of like two things I think will be really exciting applications. Thanks.
Yeah, thank you. How about you, Lian?
Yeah. My current research area is autonomous driving. I think it's a popular field over the last course of years, and a lot of remarkable development have been made in all the stages in the autonomous driving pipeline. But I still think autonomous driving is facing problems such as imbalanced data set and the safety concerns, such as the corner scenarios, for example. Like for example, imagine you are driving on the road and there's a person who is standing in front of your car and his shirt has a stop sign painted on it. And your perception system would be tricked to perceive it as a stop signal, and that may lead to undesirable result. And this kind of long tail cases is, I think it's hard for a model to guarantee all of them. So I think in the future, I'm very excited to see people come up with either more intelligent models or setting up new traffic rules to have collaboration between the road and the cars and the people. I'm excited to see how we can improve the safety concerns in the field and see a more intelligent transportation system. Yeah.
Yeah, that's really interesting. Yichen, what about you? You have anything you can share?
My current research area is actually computational biology. I think in recent years, interdisciplinary research are being greatly encouraged, especially chemistry, biology, and that, for example, psychology. Those are subjects that have many potential machine learning applications. The project I'm currently doing applies neural ODE models to predict the infection risk of a disease on banana plants. This disease is called black sigatoka. According to FAO, this disease is the most destructive disease and the most widespread disease worldwide to banana plants. And if nothing is controlled, we could lose up to 50% of banana production, which is horrible. So the aim of my research is that maybe machine learning can help farmers battle the disease and reducing the cost of banana productions by up to 40%. I found this area very exciting.
Yeah, that's great. Yeah, I think one thing that's very interesting about AI is it can be applied to many fields, like self-driving or biology or finance. So for people with industry experience, Julie, what are some possible career paths for people like you, given the skill sets and experiences you have? Will you need a master's degree?
Yeah, so the funny thing about software engineering and any engineering you really go into, the degree really helps you in the beginning. But then kind of experience outweighs the degree. So if you want to do a research type of, so there's like three paths you can go down from like my role, which is a machine learning engineer. You can kind of transition to becoming a machine learning modeler, which then, because you kind of went through that route of like from machine learning engineer to modeler, you don't need the master's degree. But if you were to go from school to go to the machine learning modeler, they prefer for you to have a master's degree. So you can kind of go either path to get there. The machine learning researcher, I feel like that from what I've read and stuff, you do need they prefer, again, master's or a PhD. It's not that you can't get it otherwise, it's just a bit harder. You need experience to back it up. So if you have, like, for example, the machine learning model or experience, then maybe you can transition to the researcher. And then the other paths are kind of just going into a more, like, you always stay a machine learning engineer, you just advance in terms of, like, you become a manager or a director, and you kind of go that path instead. So it's what they call either you stay an individual contributor and you grow in that sense, so you have more responsibilities with projects, and that's how you grow, or you grow with, like, you have more responsibilities with people, are kind of the two other paths you can take. So I'm someone who actually wants to I wanted to work first for 2 years before I went to do my master's. I'm thinking of going to do my master's. I just didn't want to do it right after university. I wanted to figure out exactly what I wanted to specialize in. So yeah, I guess that's my answer.
That's great. Thank you, Julie. How about you, Jin? What are some possible career paths for you?
Yeah, that's a great question. I think, yeah, there are probably three that I can think of. You can choose to kind of, doing a grad school, probably, either master or PhD, and then you might want to do a PhD after a master, or you can, maybe go to industry after your master. There are also some people who, will be just joining industry directly after they graduate from their undergrad. I think, then you might want to start with some software engineering roles, because I think for the machine learning or the research roles, they probably require a master degree or something like that these days. Yeah, and then I also think some people did something called kind of AI residence. Basically, it's kind of like, not exactly sure how that works, but I think it's kind of like doing a master or research-based master at a company, or something similar to that, where you spend 2 years working on research with people at big tech companies, and then that could also be a viable path. So yeah, those are the ones I can think of.
That's great. Thank you so much. And that's the end of our discussion. We'll now move on to the Q&A sessions. We'll ask Richard to monitor the Mentimeter and post interesting questions in the chat. All right, I see one. So for machine learning engineer, what are your thoughts on the importance of software engineering development skills, database language, cloud computing, etc., compared to in-depth knowledge of ML DL? Is there an ideal balance between having those software skills while also being knowledgeable about techniques and research in ML/DL? How big is the role of self-learning in ML engineers' job?
I guess that question's for me. So the importance of it, I would say, is extremely important. It is basically a software engineering role, except that you are just solely focusing on machine learning, I guess you could say related work. So you need to have those. It's a very, I feel like that's actually something that they were saying as to the reason why machine learning in production and scaling machine learning models have been so difficult, is because most of the people who focus on ML research don't have the software engineering skills to actually put those into and scale them. So then their value kind of diminishes in industry specifically. So yeah, the skills are actually very, very important. And then in terms of the second part of the question was the balance. So I was someone who, when I first started off, I did not know much about machine learning on the job. And so there was always people who were teaching me, like the opportunities. I wouldn't say it's very self-learning. It's more about like there's just like you can like ask a modeler and they'll like walk you through everything they're doing, and then you gain the experience. A lot of my coworkers, that's how they ended up learning things, right? They were software engineers by trade, and then they converted into machine learning engineers, and it was through just literally talking to modelers and getting their own kind of just getting into it themselves. But I would still say it is a bit of self-learning. I feel like as long as you have a good foundation of like you understand some ML aspects, I don't think you need to go that deep into it. You'll be fine because you'll learn a lot of it on the job. And it's very, different companies use very specific algorithms. If you go work for like Pinterest as a machine learning engineer, you're going to be very much in RL. Whereas if you go to work for Spotify, they're also doing RL stuff now, right? Whereas with me, I'm doing a lot of like deep learning stuff. So, it just depends on which company you're going to and what their kind of core business is. And you should look at that and just know at least like at a high level what that is.
Yeah, thank you. And I think most of the panelists here have internship experience. So maybe I'll ask Leanne, how big is the role of self-learning in your job?
Yeah, I think as an undergrad myself, I feel like the research experience that I had is kind of similar to an engineer. And most of the time we are writing our code to realize our models we proposed in theory. So I think if we have very good skill in PyTorch, it will speed up the research process and speed up the iteration of like if you want to add new stuff into your model, it would be very benefit. So I think software skills is very important in research too.
Yeah, thank you. And the next question, how did you get an undergraduate research positions? And how did you contact a professor who would supervise you? Maybe I will ask Colin and Jin to answer this question.
All right. Yeah, maybe I can start first. So how I did the reaching out to professor was to basically co-email a bunch of professors, the one that you're really interested in, and then basically send a resume with your transcript. And basically, what I did was I just did the due diligence of learning about what each professor does and like how I was like interested in each of the topic, and then basically talk about like my passion in the email, and don't expect a lot of response because most professors are really busy. So I think I emailed like 8 or 9 professors in my first year, and I only got like 1 response. Likely it was like a positive response. Otherwise, I won't have like any research position for that year. So I guess like the lesson learned from this is that like, email as many as you could. Don't like be like me, only message like 8 or 9. Because like the rate, the more you email, like, the more likely you get like some responses. Yeah,
definitely. I remember for my first year, I email a lot of professors too. Did you also attach cover letter in your emails, or just a transcript and resume?
So for me, I did not attach cover letter. I only attached my resume and transcript. But I think it depends on like definitely check out the website and the requirement of the professor. Usually sometimes they have like different requirements, and it's just kind of like part of the due diligence that you kind of have to do to make sure that like a professor definitely want student to actually read about their website, and then like basically it's like learn about the work, and it's actually really show your interest, right? So that's like part of like how you could show your interest in joining the lab.
Yeah, definitely read their website. How about you, Jin?
Yeah, I think Colin covered just specifically, yeah, most of them. Yeah, I think I also just cold email professors, and then yeah, basically, you shouldn't be expecting a lot of response, especially at the very beginning when you don't really have any research experience. I think that was the hardest kind of time period because yeah, you really need to start from somewhere, and then maybe you want to just email many professors and then see who will be interested in supervising you. I also know that some people, they kind of let's say they take some machine learning courses, and then after class or just at some time they will just email or talk to the professor and then ask if there's any kind of opportunity to do some sort of projects. That could also be a way to do it.
Yeah, definitely. Oh, I see another good question. The field of machine learning is changing so fast. How do you keep up with new developments in machine learning? Maybe Yuchen and Lian.
Yeah, I would say maybe Twitter is a good place to go. I think nowadays many researchers post their newly released papers on Twitter, and description and comments you can discuss on that. I think that's a good place to go.
Nice.
And to add to that, I think Medium is also a very good website for beginners especially. There are authors who translate a very professional paper into a very nicely written blog that beginners would understand. And also, I say reading papers is a very fundamental skill for all researchers. So for example, a good researcher would use their morning to read new papers and work on their own project from afternoon.
Yeah, that's great. So Medium and Twitter, yeah, those are good platforms. So the last questions for today is, what advice would you give yourself if you were freshman students again? Okay, I see Jane is laughing, so let's start with you.
Oh, I mean, I don't have any particular stories to tell this time, but yeah, I think if I would be a freshman student again, I probably would try to have a better idea what I should be doing. Because as I mentioned before, right, I kind of wasn't sure which option I should take, and then almost like by random chance that I just attend machine learning, events, and then I got interested into that. I think it would be better to know what you at least have some vague idea what you want to do at the start of your university, right? I think the reason why I chose engineering science is I wasn't too sure about what things I should be doing, and then I just wait and until the second year, and then still don't quite know. I think this is something that it's always good to think about this thing early, because you need to think about that later on as well, and then you might change your mind for sure, but it's always good to kind of see how your mind change, right? And then that's something that's also a good exercise to do. So yeah, that's my advice.
Yeah, think about what interests you. Maybe we'll ask one more person to answer this. Maybe Suyan.
Okay. I think I largely agree with James. I think, yeah, I also get into the machine learning only after my second year. And if I were to back to freshman student again, not necessarily dive right deep into the machine learning as a freshman, but I think I want to explore more research fields that interest me and have more understanding of the field. Yeah.
Yeah, definitely. Do more explorations. So joined networking event clubs, and yeah. So thank you so much for the questions, and this concludes our panel discussions. To conclude, I want to first give a huge thank you to our panelists. They were phenomenal. I hope you enjoyed the discussions as much as I did. Thank you very much. So during our panel, we heard about how to get started on learning machine learning. What are the important skills, how to find jobs and internships, and how to apply for grad school. It is really inspiring to hear how the panelists navigate through these paths and how they keep their energy up, because I think it's something that we will also encounter. And lastly, if you would like to stay connected with us, feel free to join our Discord channel. The Discord server link and website link is posted in the chat. We post resources, events, and opportunity regularly.